So in today's video I'm going to be going through oxidation, reduction and redox equations question paper from Physics and Maths Tutor. Question 1 is question about redox reaction. State in terms of electron the meaning of the term oxidizing agent, electron acceptor. Definition, classic question. Electron acceptor. It says do not allow electron pair acceptor. So if you say electron pair acceptor, no, electron acceptor. Part B, Cr2O72 minus can oxidize this in acidic solutions to form Cr3 plus SO42 minus. Deduce a half equation for oxidation of SO32 minus to SO42 minus. Well, the first thing I can notice is I have 3 oxygens here and I've got 4 oxygens there, so I need to add a H2O molecule here. But now I've added this H2O molecule for the oxygen because I can't just add oxygen directly in these half equations. Now I've added water. I've also added 2 H pluses, so I need to add 2 H pluses here. Now I've got 2 minus plus 2 H plus, that's overall charge of 0. Wait. 2 H pluses, yes. But then I also need to add 2 negatively charged electrons to get the overall charge as 2 minus. Half equation for reduction of Cr2O72 minus to Cr3 plus. So I've got 2 on the Crs on the left hand side. I need a 2 here. I also need 7 H2O molecules, 7 oxygens, but now I've got 14 H pluses, so now I need to add 14 H pluses. And my teacher always used to say this when he taught me this topic in year 12. The side you add the H pluses on is like 9 times out of 10 is most likely that's where you're going to add the negatively charged electrons. So I've got 3 plus charge here, but remember I've got 3 plus charge here because I've got 2 of them. That's going to be 6 plus charge, and then I've got a 12 plus charge here, so I need 6 negatively charged electrons to get 6 plus charge. Now the overall equation, well, I've got 2 electrons here, I've got 6 electrons here, so I need to times the first equation by 3. If I do that, I'll get 3H2O plus 3 SO32 minus arrow 3 SO42 minus plus 6H plus, and the original equation, second equation remains the same. Now what I need to do is, well, electrons, because I times it by 3, electrons are cancelled out, obviously, opposite sides. So now what I need to do is add these equations together. So I get 3H2O plus 3SO32 minus plus 14H plus plus Cr2O72 minus arrow 2Cr3 plus 7H2O plus a 3SO42 minus plus a 6H plus. However, because I've got 14H pluses here, that will become 8H plus, and that will just disappear. So 3, and also the water molecules, 7H2O here, that will disappear, so I've got 4H2O here. So I've got 3SO32 minus plus 8H plus Cr2O72 minus, forming 2Cr3 plus 3SO42 minus plus 4H2O. Perfect. So remember that final part of just cancelling out H2O molecules and H pluses, that's a very common part I think students don't get correct. Question 2, which compound contains a chlorine atom with oxidation state of +4? In part A, potassium +1, oxygen -2, 10 by 4 -8, so that's going to be +7 chlorine. In part B, chlorine is going to be definitely not +4 because there's 4 of them, so no. Part C, it is going to be +4. Oxygen -2 times by 2 -4. Therefore, chlorine must be +4 to get overall charge of 0. NO2 minus ions can be reduced in acidic solution to NO. How many electrons are gained? Go from -1 charge to neutral charge. 1 electron is gained. Question 4. Which compound contains chlorine in the oxidation state of +1? +1. Okay. So, part A. Yeah, part A will. Because oxygen is -2. Therefore, chlorine must be +2, but it's 2 chlorine, so chlorine is +1. Yeah. Which conversion is metal reduced? A metal. So in this case, Cr is metal in part A. So -14 for oxygen, -2 times by 7 -14. That's going to be +6 because it needs to be +12 to get -2. But it's 2 of them, so it's +6. -8, that's going to be +6. Oxygen -2 times by 4 -8, that's +6 to -2. So that's not reduced. Nothing happens at oxidation state. In part B, -8, that's +6. And in this case, it's -8, that's +7. In part C, -4, +4, -6, +4, -6, +4, -2. Yeah, that's not happening. And in part D, -6, that's +5 to 2 plus, so the overall oxidation is 2 plus. Well, that's going to be +4, isn't it? So the answer is clearly going to be a D, because metal reduced oxidation state goes down. Part 6, question 6, which equation does not represent a redox reaction? So I've got oxidation state of 0 here. In this case, it's -1 times by 2 -2, that's +2. And in this case, it's +1. In this case, 0. So the oxidation state increases, the oxidation state decreases, therefore oxidation and reduction does happen, so therefore is a redox reaction. In part B, that's going to be, well, in this case, it's going to be O2, 0. And in this case, it's going to be, well, oxidation state, well, carbon is in group 4, so that's going to be +4. In this case, oxidation state of carbon in methane. Well, the oxidation state of carbon is going to be -4. In that case, it's +4. And in this case, yeah, for therefore oxidation and reduction does happen because CH carbon -4 to +4, oxygen 0 to +4 or +2. Yeah, that is reduction. A redox reaction. In this case, 0 because element by itself, -8, -2, sulfur group 6, +10. Oxidation state of Fe in FeSO4. As you know, because SO4 2 minus, so the SO4's got overcharged 2 minus, therefore Fe must have a +2 charge to get overcharged 0. So 0 to +2, and in this case, again, SO4 2 minus is CuSO4, therefore copper is +2 to 0. So oxidation and reduction does happen, so it is a redox reaction. +2 to 0, 0 to +2. Therefore the answer must be D. And if I look at D, copper in this case is +2. Copper in this case is +2. And if I look at hydrogen, that's -1, that's +1. -2, that's +1. So the oxidation state does not change. Not oxidation, neither reduction happens. Question 7, V2O5 can be used as a catalyst contact process. Which is a step in the contact process in which vanadium is oxidized? The answer is clearly going to be C. You do need to know these equations off by heart in the contact process. Which of these is redox reaction? So redox reaction, oxidation and reduction happens. So in this case, calcium CaO, oxidation state of calcium and CaO. Well, oxygen is -2. Calcium, yeah, it's going to be +2. And in this case, minus SiO3, Si, that's in group. What group is that in? Is that in oxidation state of calcium in CaSiO3? Well, it should definitely be, well, SiO3, same with SO3 2 minus, it's SiO3 2 minus, so it should be +2. Therefore, redox does not redox reaction does not happen. Oxidation state does not change. Part B. Let's look at sulfur -8. Oh, again SO4 2 minus. Let's look at hydrogen actually. SO4 2 minus, so that's overcharged with -2, so that means hydrogen must be +2, whereas 2 hydrogens, therefore it's +1 to, in this case, -2 +1. So redox does not happen in part B. In part C, NABR. Well, actually, let's look at this bit, H2SO4. SO4 2 minus, therefore hydrogen must be +1. And if I look at here, hydrogen in this case, well, I've also got SO4 2 minus, so that's -2. Sodium group 1 is going to be +1, so that's going to be -1, therefore hydrogen must be +1. Therefore, that is also not a redox reaction. Therefore, I'm left with this one, where magnesium is 0, sulfur is 0. Magnesium, that's +2, -2. Oxidation state increases, decreases. Therefore, the answer is D. Oxidation state of magnesium in magnesium S. Perfect. Question 9. Which of these species is the best reducing agent? So the best reducing agent. So I'm looking for the best oxidizing agent. I look for the positive. I'm looking for the most negative ion. I'm looking for the negative ions, not most negative ions. It's not going to be A. It's not going to be C. So it's either B and D. And if we look at the periodic table, iodine is going to be iodine. I minus is the best reducing agent. Best in this case. Best reducing agent. Question 10. In which reaction is metal oxidized? Okay, this one is tricky because I've got these metal aqua ions, I'm pretty sure, which I haven't even gone through in class. However, I have gone through it by myself, so I've got like some level of, a tiny bit of level of experience on this topic. In which reaction metal oxidized? So 2Cu2 plus, well, that's obviously just going to be +2. Don't care about the moles. 4I minus, that's also going to be -1. We don't care about that. The metal oxidized. So metal oxidized. So in this case, I minus, that's going to be +1, isn't it? Oxidation state of copper in CuI. Should be, yeah, +1. So that is clearly not oxidized. Because look at the question before, which metal reduced, oxidation state goes down. So which is the metal oxidized? Oxidation oxidation state goes up. If I look at B, I'm not really confident with working out the oxidation state of the metal in these kind of questions, but I can already see at D, well, magnesium 0 in this case, that's -2. No, that's also 0. And that's +2 magnesium, and that's -2. Oxidation state goes up, metals oxidize, so the answer is D. 10. D. I'll give explanation why, as the oxidation state goes up. Okay, a couple more questions left. In which reaction is hydrogen acting as an oxidizing agent? So, oxidizing agent, electron acceptor. Just go back down. Electron acceptor. So now we've got it in like some terms we can understand. So accept an electron. In this case, that's 0. That's obviously going to be 0. They're just elements by itself. And in this case, that's hydrogen's going to be +1. Chlorine's going to be -1. Is hydrogen acting as an oxidizing agent? So it accepts electron. Does it accept an electron in this case? No, it doesn't. No. Let's look at D. If I look at D, forget the moles, that's 0, that's 0. And in this case, hydrogen, because if hydrogen is going to accept an electron, it's going to be -1, right? It's going to have a negative charge. In Na plus, NaH, now it's going to be Na is going to be positive, hydrogen is going to be -1. Because the oxidation state of sodium in sodium H is clearly going to be +1. So therefore, hydrogen acts as an oxidizing agent because it's accept an electron, because it's gone from 0 to -1, and the only way to go from that is accepted a negatively charged electron. So therefore the answer must be D. If I look at C and if I look at B and C, if let's look at C, that's 0, that's 0. 2 NH2, don't care about that. Nitrogen, well, that's going to be -3. Hydrogen is going to be +1. Because the oxidation state of nitrogen in ammonia is going to be -3. So therefore, it's not act as an oxidizing agent. Because it's gone from 0 to +1, it should go from 0 to -1. And if I look at B, this one's a lot more complicated because it's not like as simple. It's not 0, 0 to something else. It's shit 3, 2, CO. But actually, I don't even need to. I look at here. That's 0 hydrogen. Anything else, just hydrogen. Then look at this case. Well, CH3 2. Well, CH3 2 CHOH. Oxidation state of hydrogen in CH3 2 CHOH. Well, this is obviously going to be methane, propanol. No, CH3. Yeah, it's not going to be B as well. Question 12. Which of the following shows chlorine is correct oxidation states in the compounds shown? Chlorine in HCl should definitely be -1. So it's not going to be B or D. That says +1. In this case, well, potassium is going to be +1. Oxygen -2 times by 3 -6. Therefore, chlorine is going to be +5. So the answer is going to be C. Which of these shows nitrogen's correct oxidation state of the compounds given? Nitrogen should be hydrogen +3, nitrogen -3. So it's not going to be A, it's not going to be D. In this case, oxygen -2, that should be +1. Oh no, but both of them are +1. So now it's the final one that determines whether it's B or C. Well, oxygen -2 minus 4 plus 1 should be +3. So it is B anyway. And in question 14, the final question, which of these is not a redox reaction? Well, if I look at Cu2O, let's just look at the metals, right? Metals. Okay, so in this case, -2, that's going to be +1. In this case, it's going to be 0. That is reduction. And in this case, minus CuSO4, -2 times by 4, -8. No, SO42 minus, remember the iron, so that's overcharge of -2, so that's got to be +2. So it does, oxidation state does increase, oxidation state does decrease, therefore is a redox reaction because reduction and oxidation happen simultaneously. Look at B, MgO, -2, that's +2. Like in this case, that's -2, that's going to be +2. And if I look at, let's say, yeah, so that's not going to be a redox reaction. That's simple. Because the oxidation state of the metal is stayed the same. It's not changed at all. And that is the end of oxidation, reduction, and redox reactions question paper from PMT. One thing to take from this lesson, obviously this topic is a lot about practicing, like in this, and also the multiple choice questions. Go through all of them at least twice before your exam, so you're very comfortable with them. And also memorize the definitions. Oxidizing agent is electron acceptor, not pair acceptor, electron acceptor. That is the end of this video.